Imagine standing beneath a sky of permanent cloud. No sunrise, no nightfall, only a dim orange haze glowing with trapped heat. The air is so thick it could crush a submarine. The ground itself glows faintly red, hot enough to melt lead. Every breath would be poison. This is not some mythic underworld. It is real. It is a world that, billions of years ago, might have looked almost exactly like Earth. Its name is Venus, our planet's twin in size, composition, and origin. Yet, somewhere in the deep timeline of the solar system, this twin took a path so different, so catastrophic, that it became the closest thing to hell ever found in nature. How did that happen? For decades, astronomers have looked at Venus as a mirror, sometimes flattering, sometimes terrifying. Its mass is almost identical to ours. Its orbit hugs the inner edge of the so-called habitable zone, the region where liquid water should exist. And for the first half of the 20th century, scientists even imagined Venus as a tropical paradise. A vast rainforest world wrapped in warm mist, teeming with strange life. But when the first probes arrived, the dream evaporated instantly. The thick white clouds weren't made of water vapor, but sulfuric acid. The warm mist was a superheated atmosphere, dense enough to crush metal, and beneath it all lay a scorched desert of stone and molten lead. The surprise was so violent that some scientists compared it to a religious revelation. Venus, the planet of love, was also the embodiment of damnation. Still, one haunting question refused to fade. Was it always like this? Could Venus have once been Earth's twin in truth? Blue oceans, white clouds, rain, rivers, even life, and then lost it all? In November 2005, a small European spacecraft called Venus Express launched from Kazakhstan atop a Russian Soyuz rocket. Its mission: to travel 250 million miles through the void and uncover the planet's forgotten history. For 4 years, it would orbit this infernal world, armed with advanced infrared sensors and instruments built to peer through the acid clouds. What it found would challenge everything we thought we knew about climate, evolution, and the fragility of planetary life. The story of Venus is not just about another planet. It's about our future, because hidden in that hellish sky is a warning, a vision of what happens when a world's atmosphere turns against it. Scientists call it a runaway greenhouse effect. On Earth, we know the term well. Rising carbon dioxide, global warming, melting ice caps. It's the same process that once transformed Venus from Eden to Inferno. Some researchers believe that Venus began with oceans, deep enough to cover 90% of the planet. It may have had rain, clouds, even lightning. In that ancient mirror world, life could have had a chance. But something changed. Slowly, the oceans vanished. The air thickened. Carbon dioxide, once a trace gas, became the atmosphere itself. And the planet's surface temperature climbed to over 900 degrees Fahrenheit. Venus is what happens when a planet crosses a point of no return. The mission of Venus Express wasn't just to map craters or measure gases. It was to find out why. Why did two worlds born from the same cosmic dust end up so utterly different? And could the same fate, someday, be waiting for Earth? In the silence of space, Venus shines as the brightest object in the night sky, so dazzling that ancient cultures called it the morning star, the bringer of light. Yet, through the telescope, that light hides a darker truth. What lies beneath those clouds is a world of fire and pressure, a world that has devoured its own oceans, a world that reflects not only sunlight, but our own possible destiny. In the coming story, we'll travel with the engineers and scientists of the European Space Agency as they navigate the perilous orbit of Venus, diving through its toxic atmosphere and decoding the mysteries buried beneath. We'll uncover how the planet lost its water, why its winds circle the globe 60 times faster than its rotation, and how its volcanoes may still be active today. And then we'll face the most disturbing question of all. If Venus once had oceans and lightning, if it had the ingredients of life, could something somewhere in those acid clouds still be alive? This is not just a journey to another world. It is a mirror held up to our own. A reminder that paradise and apocalypse can share the same face, separated only by a few billion years of sunlight. Welcome to Venus, Earth's lost twin. Part 1. The launch of Venus Express. It is the early morning of November 9, 2005. The temperature in Baikonur, Kazakhstan, hovers just below freezing. At the edge of the desert, a Soyuz Fregat rocket stands poised against the dawn, steam curling around its hull. Its payload, a spacecraft no larger than a family car, carries the weight of one of humanity's most ambitious planetary investigations. The countdown begins. At 3:33 Universal Time Coordinated, the ignition sequence roars to life. Fire and ice explode together, and the Soyuz climbs into the sky, carrying Venus Express, the European Space Agency's first dedicated mission to our planet's sister world. It is a strange moment in history. For nearly 2 decades, no human probe has visited Venus. Mars has captured nearly all attention, with its red dust and whisper of habitability. But for a small team of scientists in Europe, the mystery of Venus has never faded. They see it not just as a dead world, but as a laboratory, a warning, and perhaps even a time capsule of Earth's possible future. As the rocket pierces the stratosphere, telemetry signals flash across consoles in ESA's control center in Darmstadt, Germany. The spacecraft separates perfectly from its launch vehicle and begins its 250 million-mile journey toward the inner solar system. Venus Express will not arrive for 5 months. During that time, engineers run countless system checks, guiding it through the void with surgical precision. The probe's route is a delicate spiral around the Sun, its trajectory designed to match Venus's orbit to within a few hundred kilometers. Mission manager Dr. Don McCoy recalls, "Space is never safe. You plan for everything: radiation, micrometeorites, power failures, but there's always the unknown. Venus isn't just another planet. It's a furnace wrapped in acid." Approaching the inferno by April 2006, the spacecraft nears its destination. From 20 million miles away, Venus appears as a pale white disk, smooth and almost innocent. But the numbers tell a different story. An atmosphere 90 times thicker than Earth's, temperatures near 900 degrees Fahrenheit, and winds that scream around the planet at 200 miles per hour. The insertion into orbit will be the most dangerous part of the mission. The spacecraft must slow down by 3,000 meters per second, a precision maneuver performed automatically with no room for error. If the engines fire too long, Venus Express will crash into the planet. If too short, it will slingshot off into deep space forever. At 9:47 Universal Time Coordinated, April 11th, the command is sent. The spacecraft disappears behind the planet. For 10 minutes, mission control loses all contact. The radio silence is absolute. The engineers can do nothing but wait. In those 10 minutes, years of planning hang in the balance. Then, at 9:57, a signal returns. Weak at first, then strong. Venus Express is in orbit. Applause breaks out across the control room. But relief quickly gives way to focus. The mission has just begun. The hidden world beneath the clouds. Venus's greatest mystery is not what we see, but what we can't. Its surface has been invisible to telescopes for centuries, hidden beneath a dense shroud of yellowish cloud. Even radar can reveal only outlines. Early astronomers once believed those clouds were made of water vapor, that Venus might be a steamy jungle world. In the 1950s, textbooks described it as Earth's tropical twin, a planet of swamps and ferns. The truth, when revealed by Soviet probes in the 1970s, was devastating. The Venera missions, brutal, short-lived landers, had transmitted images of a scorched plain, littered with rocks and lifeless dust. The atmosphere was pure carbon dioxide, with droplets of sulfuric acid suspended like poison rain. Each lander survived less than an hour before being crushed, corroded, and melted. Yet, even in failure, the Venera data hinted at deeper questions. Why were Venus and Earth, born from the same solar nebula, so different? What triggered the runaway greenhouse that turned one world into hell while the other became home? Venus Express would attempt to answer those questions not by landing, but by looking through the clouds. Its instruments are tuned to infrared wavelengths, light invisible to the human eye, but capable of penetrating parts of the dense atmosphere. From orbit, the spacecraft can map the planet's surface temperature, measure chemical compositions, and even detect faint heat signatures of volcanic activity. For the first time, scientists can see Venus in 3 dimensions, from its upper atmosphere down to its smoldering crust. A world of pressure and fire. What they discover in the first few months is staggering. Beneath the endless clouds lies a landscape of unimaginable violence. More than 85% of Venus's surface is made of solidified lava. It is a planet of volcanoes, hundreds of thousands of them, now mostly extinct. The atmosphere presses down with the force of an ocean trench. If you stood on the surface, the pressure would crush a car flat. The air glows faintly red from the heat, and the rocks themselves radiate light in the infrared spectrum. There is no water, no visible life, no escape from the heat. And yet, somehow, the planet's clouds swirl in perpetual motion. Massive winds circle the globe in just 4 Earth days, a phenomenon scientists call superrotation. How can a world that spins so slowly, one day on Venus lasts 243 Earth days, have winds so fast they outpace the rotation by a factor of 60? The question haunts the mission team. Every measurement, every infrared scan, deepens the mystery. The search for the lost ocean Venus Express soon detects something strange at the edge of the planet's atmosphere. A stream of escaping particles, hydrogen, helium, and oxygen, bleeding into space. These are the basic elements of water. It is a ghostly signature, the last breath of something long gone. Scientists begin to piece together a story that sounds almost tragic. Billions of years ago, Venus might have had oceans vast enough to drown its continents. But closer to the Sun, the planet received nearly twice as much solar radiation as Earth. Over time, the seas evaporated, filling the atmosphere with water vapor. Without a magnetic field to protect it, the planet was defenseless. The solar wind, a stream of charged particles from the Sun, stripped away the hydrogen atoms, leaving the oxygen behind. Slowly, molecule by molecule, the oceans vanished into space. What remained was a dense, choking blanket of carbon dioxide. The greenhouse effect spiraled out of control. The surface baked, the pressure rose, and the planet crossed a threshold from which there was no return. Venus, the mirror of Earth, had become its warning. The Venus Express mission will spend years circling this world, unraveling its secrets layer by layer. It will reveal storms that dwarf anything on Earth, lightning made of sulfuric acid, and perhaps even signs of volcanic activity still flickering beneath the clouds. But as the data flows back to Earth, a deeper and more unsettling realization begins to emerge. What happened to Venus is not just history. It's a glimpse of what could happen here. The difference between paradise and oblivion, it turns out, may be thinner than a layer of clouds. Part 2. The infernal mirror. Billions of years ago, 2 planets were born side by side in the same swirling cradle of dust and fire. They shared a star, a neighborhood, and a beginning. Their orbits formed less than 40 million kilometers apart, close enough to see each other in the early skies. They were cosmic twins, Earth and Venus. From space, the resemblance is uncanny. Both are nearly the same size, Venus just a few hundred kilometers smaller in diameter. Both are made of the same silicate rocks, the same iron core, the same trace elements left over from the Sun's formation. Each was molded by volcanoes, reshaped by impacts, and likely cloaked by thick primordial atmospheres. For billions of years, the 2 worlds spun quietly under the same sun. Yet one would become a cradle of oceans, forests, and life, while the other descended into an abyss of fire. How did the mirror crack? The first dawn in the earliest age of the solar system, about 4.5 billion years ago, both planets endured the same brutal childhood. The Sun was still young and unstable, flaring violently. Asteroids rained down like bullets of molten metal. Entire mountain ranges formed overnight and vanished the next day in oceans of magma. During this period, known as the Late Heavy Bombardment, the surfaces of both Earth and Venus were oceans of liquid rock. Their atmospheres were toxic, dominated by carbon dioxide and sulfur compounds. But as the planets cooled, something miraculous happened. On Earth, volcanic steam condensed, clouds formed, rain fell, and for the first time oceans appeared, vast bodies of water that would one day cradle life. Venus likely followed the same pattern. Geological models suggest that in its first few 100 million years, Venus's surface temperature was low enough for liquid water to exist. Some scientists estimate that as much as 90% of the planet's surface might have been covered by ocean's shallow, tropical seas shimmering under a yellow sun. It was a world of perpetual daylight. Because Venus spins so slowly, one rotation takes 243 Earth days. Its days and nights stretched into endless seasons. Warm, humid air circulated lazily around the globe. Lightning flashed across stormy skies. By all appearances, Venus could have been a paradise. And then, something changed. The slow spiral, the key difference between Earth and Venus lies in one simple fact. Distance from the Sun, Venus orbits roughly 30% closer, which means it receives nearly twice as much solar energy. In the early eons, that extra heat may not have mattered much. But over time, it became deadly. On Earth, sunlight warms the oceans, water evaporates, and the vapor forms clouds that reflect some of that sunlight back into space. A natural thermostat. Venus's clouds, however, formed lower in the atmosphere and trapped more heat than they reflected. As the surface warmed, more water evaporated. And as the air filled with vapor, the planet's greenhouse effect began to spiral. Water vapor is a powerful greenhouse gas. Once it reached a certain concentration, the feedback loop became unstoppable. The oceans boiled. The atmosphere thickened. Carbon dioxide, once locked in rocks and sediments, was released back into the air. Venus had entered a phase scientists call the runaway greenhouse effect. It's the same process that keeps Earth warm enough to live, but on Venus it went out of control. The difference between a temperate world and an inferno, it turns out, is just a few degrees of equilibrium. The Great Divergence, meanwhile, Earth evolved in the opposite direction. As volcanoes exhaled carbon dioxide, liquid water and early microbial life pulled it from the air and trapped it in carbonates and limestone. The greenhouse stabilized. A fragile balance was born, one that would one day make blue skies and green continents possible. Venus had no such chance. Its rotation is so slow that one day lasts longer than its year. Without a fast-spinning molten core, it failed to generate a magnetic field like Earth's. That magnetic shield protects our planet from the solar wind, a river of charged particles that constantly blasts from the sun. Without it, Venus's atmosphere was left exposed. The solar wind began stripping away the lightest elements, hydrogen and helium, into space. Hydrogen, the key ingredient of water, was the first to go. Over hundreds of millions of years, Venus's oceans quite literally evaporated into the void. What remained behind was a dense, suffocating envelope of carbon dioxide and sulfuric acid. The surface pressure rose to 90 times Earth's, the equivalent of standing under a kilometer of ocean. And the temperature climbed relentlessly toward 475 degrees Celsius, 900 degrees Fahrenheit. The planet was transforming slowly, inexorably, from a blue twin into a blazing mirror of our worst nightmare. Ghosts in the clouds to this day, the clouds of Venus remain both its veil and its enigma. They hide everything beneath them but also carry clues to the planet's lost past. Composed primarily of sulfuric acid droplets, these clouds are unlike anything else in the solar system. Through Venus Express's infrared sensors, scientists detected faint layers within the clouds, some cooler, some warmer. In those cooler regions, about 50 kilometers above the surface, the temperature drops to around 70 degrees Celsius, 160 degrees Fahrenheit. Still brutal, but survivable for certain types of microbial life known on Earth as extremophiles. If Venus ever hosted life, this is where it might have retreated, high above the furnace, clinging to survival in the acid mist. The idea seems absurd, but the evidence is haunting. In ultraviolet light, Venus's cloud tops reveal dark patches that absorb sunlight far more efficiently than sulfuric acid should. These patches shift and change shape like weather patterns. No one knows what they are, Some scientists have suggested they could be aerosolized compounds of sulfur and iron. Others whisper a more radical idea. Perhaps they are colonies of microbial organisms, suspended in the atmosphere, using sunlight for energy. No one has proven it. No one can. But the possibility keeps returning, like a reflection we can't look away from. The mirror that warns. When the data from Venus Express first arrived, scientists were stunned by how familiar some of it looked. The processes that destroyed Venus, carbon dioxide buildup, loss of magnetic protection, runaway heating, are the same mechanisms that Earth now experiments with on a smaller scale. Our planet is nowhere near Venus's fate, at least not yet. But the warning is written across the sky of our sister world. The climate can change faster, more violently, and more permanently than anyone expects. Venus is the ultimate climate laboratory, says planetary scientist Dr. Colin Wilson of the University of Oxford. If we want to understand global warming, we have to study the planet where it went to its logical extreme. Venus shows us what happens when a planet's delicate balance collapses. It's not a cautionary metaphor. It's a physical reality, orbiting just next door. In the next chapter of this story, Venus Express will venture deeper into the storm, descending through the clouds, mapping the superheated atmosphere, and revealing one of the strangest meteorological engines in the solar system. From hurricane-like vortices at the poles to winds that race faster than sound, Venus is about to show us that even in death, it is alive with motion. Part 3. The Winds of Hell. From orbit, Venus looks deceptively calm, its surface forever hidden beneath a smooth, yellow-white layer of cloud. But beneath that placid mask lies an atmosphere in constant, violent motion. For a world that spins slower than any other planet in the solar system, Venus's winds move with breathtaking speed. When Venus Express began its long, elliptical orbit, it carried instruments capable of tracking minute temperature changes and subtle shifts in cloud texture. What it discovered astonished the mission team. Winds circling the planet at over 200 miles per hour, racing around the globe in just 4 Earth days. This phenomenon became known as superrotation, and to this day, it remains one of the most extraordinary meteorological mysteries in the solar system. The paradox of motion. To understand why this discovery was so strange, imagine a world where the day is longer than the year. A single rotation of Venus one day takes 243 Earth days. A single orbit around the Sun takes 225 days. In other words, Venus's day is longer than its year. Its surface moves so slowly that you could walk faster than the planet spins. By all logic, such a slow rotation should mean sluggish winds. On Earth, rapid rotation helps drive the circulation of air, creating jet streams, hurricanes, and the Coriolis effect that gives storms their spin. But Venus defies this logic completely. The solid planet crawls. The atmosphere races. What force could drive an entire planet's air to move 60 times faster than the ground beneath it? Into the cloud deck to find out, Venus Express turned its cameras toward the planet's poles, where the atmospheric currents converge. From the spacecraft's perspective, the poles of Venus look like great maelstrom, vast vortices that spiral down through the clouds like cosmic whirlpools. The south polar vortex alone stretches over 1,200 miles wide and plunges 8 miles deep. Inside it, winds spin at hundreds of miles per hour, forming not one but two eyes, like a double hurricane fused together. Dr. Giuseppe Piccioni, one of the mission's lead scientists, recalls his reaction the first time the data came in. "We had expected turbulence, yes, but not this. It was alive. The vortex seemed to change shape every time we looked at it. The images showed shifting ovals, spiraling tendrils of cloud, even hourglass patterns forming and collapsing over hours. On Earth, hurricanes derive their power from the ocean's warmth. But Venus has no oceans. What fuels these titanic storms? The heat engine. The answer, scientists now believe, lies in the way sunlight interacts with Venus's thick atmosphere. Even though the surface never sees direct sunlight, the upper clouds absorb massive amounts of solar energy. The heat is trapped, bouncing between the cloud layers and the surface below, creating a powerful thermal gradient. hot air rising at the equator, cooler air sinking at the poles. This motion sets the entire atmosphere spinning, and because the planet itself rotates so slowly, the energy has nowhere to dissipate. Over centuries, the momentum builds, whipping the upper atmosphere into perpetual superrotation. It's as if the entire sky of Venus has detached itself from the ground, forming a planet-sized jet stream. At certain altitudes, these winds reach 250 miles per hour, fast enough to encircle the planet in just 96 hours. By contrast, the ground beneath them takes 5,832 hours to make one turn. The atmosphere of Venus, in effect, has a mind of its own. The whirlwind laboratory back on Earth, physicists struggled to model this impossible behavior. One of them, Dr. Peter Reed at Oxford, decided to recreate Venus's atmosphere using a rotating tank of water heated from below. The water represented the thick gas layers, the rotating base simulated the planet's slow spin, and the temperature difference between top and bottom mimicked the solar energy gradient. When the experiment began, the water moved gently. But as the heat increased, the entire layer started to swirl faster and faster, until, suddenly, a coherent pattern emerged. A vortex wrapped around the poles, circulating at high speed. It was a miniature version of Venus's atmosphere. Dr. Reed described it as an atmosphere that refuses to rest. Venus, it seemed, had become a self-sustaining heat engine, a world where the air moves not because the planet turns, but because it cannot stop itself. Lightning in the clouds if the winds weren't strange enough. Venus Express soon detected another, even more puzzling phenomenon. As the spacecraft passed through the night side of the planet, its instruments picked up brief bursts of low-frequency electromagnetic noise, tiny whistles in the darkness. To the untrained ear, they sounded like static. But to the mission team, they were unmistakable, lightning. The finding shocked many scientists. On Earth, lightning is born from collisions of water droplets and ice particles inside thunderclouds. But Venus's atmosphere is bone-dry, composed mostly of carbon dioxide and sulfuric acid. There are no oceans, no rainstorms, no obvious way for electrical charges to form. So what was causing these flashes of power? One explanation pointed to the sulfuric acid clouds themselves. Just as water droplets on Earth can build up static electricity through friction, so too can acid droplets colliding in Venus's turbulent winds. The constant motion of superrotation provides the friction, while the dense atmosphere acts as a capacitor, storing charge until it discharges in massive arcs, lightning without water. Dr. Christopher Russell of UCLA, who had long theorized about Venusian lightning, described hearing the first confirmed signal as a personal victory. It meant that even in the planet's alien atmosphere, familiar forces of nature were still at work. Lightning means energy, and energy means chemistry. For astrobiologists, this raised a thrilling possibility. Lightning on Earth is known to create complex molecules, amino acids, nitrates, the building blocks of life. Could the same process be occurring in Venus's clouds today? The living tempest with every orbit, Venus Express revealed more layers of motion. It observed not just global winds, but localized wave patterns, atmospheric ripples thousands of miles long that shimmer across the upper clouds like the surface of a boiling sea. Some of these waves travel against the direction of the superrotation, hinting at powerful interactions between different atmospheric levels. Others appear stationary, locked in place by mountains far below, a clue that even on a planet shrouded in cloud, the landscape still shapes the sky. Scientists began to realize that Venus's atmosphere behaves less like weather and more like a living organism, pulsing, shifting, and endlessly recycling energy. It is a world where storms never end, where thunder flashes in acid skies, and where the winds howl without pause, circling a planet that forgot how to spin. The mirror's edge in studying these chaotic winds, researchers found something else, something deeply unsettling. The processes driving Venus's superrotation and runaway greenhouse effect are governed by the same physics that operates on Earth. The only difference is intensity. Our world, too, has jet streams and polar vortices. We, too, depend on the delicate balance between sunlight, rotation, and atmospheric feedback. On Venus, that balance collapsed. And once it did, the planet's own weather began to destroy it further, a cycle of heat feeding motion feeding heat. It's a reminder that planetary climates are not eternal. They are fragile systems that can change beyond recognition. Venus didn't simply die, transformed into a world of perpetual storm. In the next chapter, Venus Express will look downward, through the clouds, into the infernal surface itself. What it finds there: vast lava plains, dormant volcanoes, and the possible signs of eruptions still glowing in the dark, will challenge the belief that Venus is a dead planet. Because beneath that crushing heat and endless wind, something may still be alive, if not in biology, then in fire. Part 4. The planet that burned itself alive. When Venus Express first began to peer through the planet's dense veil of cloud, scientists expected to find a world geologically quiet, a fossilized husk, frozen in its fiery state for billions of years. Instead, what they uncovered was something more complex and far more dramatic. Venus, it turned out, might not be dead at all. Through its infrared sensors, the spacecraft revealed that nearly 85% of the planet's surface is covered in volcanic rock, plains of basalt, vast lava fields, and mountains that stretch thousands of miles. It was as if the entire planet had once erupted in unison. The data suggested that most of the surface is relatively young, perhaps less than 500 million years old, a blink of an eye in geological time. But how could an entire world resurface itself? The silent volcanoes. To understand this mystery, we must look to Earth. Here, volcanoes form along fractures where tectonic plates move apart or collide. The motion of those plates, Earth's mobile crust, releases heat from the planet's interior in a steady, regulated flow. It's a planetary safety valve. Venus has no such relief system. Its crust is a single, solid plate, locked in place like armor. The planet's interior heat, generated by radioactive decay and residual formation energy, has nowhere to go. For hundreds of millions of years, it builds pressure beneath the surface, trapped by that immovable shell. Eventually, the pressure becomes too much. Like a kettle without a vent, the planet erupts, not in one place but everywhere. The crust cracks open, magma floods across continents, and in a geological instant, the surface is wiped clean and renewed. Scientists call this process catastrophic resurfacing. If this model is correct, Venus didn't just experience volcanic activity, it was consumed by it. The planet literally burned itself alive. The evidence in stone Venus Express's infrared mapper, Virtus, allowed scientists to see through gaps in the cloud cover and detect subtle variations in surface heat. Those measurements revealed temperature anomalies, warm patches scattered across the planet's highlands and volcanic plains. At first, the mission team thought these might be artifacts of measurement or differences in rock composition. But when they cross-referenced the data with earlier radar maps from NASA's Magellan mission in the 1990s, the anomalies lined up perfectly with known volcanic structures. Some of these regions showed heat signatures that changed over time, a possible sign of active lava flows. If confirmed, it would mean that Venus is still geologically alive. In 2010, a team led by Dr. Eugene Shalagian analyzed several such hot spots in the region known as Ganiki Chasma, a massive rift zone near the planet's equator. They found that the surface brightness fluctuated over days, suggesting cooling lava only a few weeks or months old. It was the first real evidence of modern volcanic activity on Venus. The breadth of the planet further proof came from Venus Express's spectrometers, which measured the composition of gases in the upper atmosphere. One element, in particular, caught scientists' attention: sulfur dioxide, SO2. On Earth, this gas is released mainly by volcanic eruptions. Venus's atmosphere is rich in sulfur compounds, but what puzzled researchers was how much the levels of SO2 varied from year to year. Such fluctuations imply that new gas is being injected from below, that is, from erupting volcanoes. Sulfur dioxide is the breath of a living planet, explains Dr. Håkan Svedum, the Venus Express project scientist. If you see it changing, it means something underneath is still breathing. The data didn't just rewrite the story of Venus's geology, it revived it. A world of fire and pressure. To appreciate the scale of this activity, imagine standing, if you somehow could, on the Venusian surface. The sky is a dim orange, the sunlight filtered through clouds of acid. The air presses against you with 90 times Earth's atmospheric pressure, enough to crush a submarine. The temperature is 900 degrees Fahrenheit, 475 degrees Celsius, hot enough to melt lead. In the distance, the horizon ripples like water. That's not a mirage. The rocks themselves glow faintly red from the heat. Now imagine the ground trembling. From a fissure several miles wide, molten rock bursts upward, spreading in rivers that stretch for hundreds of miles. There is no sound. Sound cannot travel through air this dense in the same way, but the ground shakes like a living creature's heartbeat. Within hours, the lava hardens into a glassy plain, and the cycle begins again elsewhere. Venus's landscape tells this story over and over. Smooth lava seas stretch for thousands of kilometers, punctuated by pancake domes, broad, flat volcanic mountains formed by slow, viscous magma. Impact craters are rare, meaning most were erased by resurfacing. It is a planet that renews itself through destruction. The ancient cataclysm geologists believe the last global resurfacing event on Venus occurred about 500 million years ago, releasing enough magma to cover the entire planet in molten rock. To visualize this, Dr. David Grinspoon, a planetary scientist, once performed a simple but haunting demonstration. He filled a pan with pudding, placed it on a hot plate, and waited. As the base heated, cracks began to form on the surface. When he pushed the temperature higher, the pudding's crust ruptured, and liquid erupted from below, flooding everything. That, he said, is Venus. The resurfacing likely took tens of millions of years, a geological blink, resetting the planet's surface and atmosphere. Trillions of tons of carbon dioxide and sulfur dioxide spewed into the sky, thickening the already toxic air. Any trace of earlier oceans, mountains, or perhaps even life would have been obliterated. Venus had erased its own history. The flickering glow. Despite the planet's hostility, Venus Express managed to capture glimpses of something strangely beautiful. Faint glowing patches on the night side of the planet, seen only in the infrared spectrum. These glows, scientists believe, are regions of still warm rock, places where volcanic vents or fresh lava continue to radiate heat. In some images, the glows appeared to move or change shape over time, hinting that the planet's surface remains active even now. If true, that means Venus's catastrophic resurfacing may not have been a one-time event, but a recurring pulse, a planetary heartbeat that continues in slow motion. Venus, it seems, is still burning. The consequence of heat. The volcanoes of Venus did more than shape its terrain. They reshaped its destiny. Each eruption injected enormous amounts of greenhouse gases into the atmosphere, feeding the runaway effect that transformed the planet. The more it erupted, the hotter it became. The hotter it became, the more its surface melted, releasing still more gas. It was a feedback loop of geological suicide. And yet, in this inferno, the planet may still harbor secrets. The detection of phosphine gas in Venus's clouds in 2020, long after the end of the Venus Express mission, rekindled debates about possible life. Some argued that it was the chemical fingerprint of unknown microbes. Others suggested volcanic or photochemical origins. Whatever the answer, one thing is clear. Venus is not a silent, fossilized rock. It is a world of motion, pressure, and transformation, a living system of fire. In the next part of our journey, the Venus Express team will turn their attention upward again, to the planet's strange atmosphere, its chemical mysteries, and the puzzle of where its oceans went. There, among the sulfuric clouds and escaping particles, lies the answer to how a paradise drowned in its own sky. Part 5. The ocean that vanished into the sky long before Venus became a furnace. It may have glittered blue. Oceans once rippled under a yellow sun, fed by rainfall and cloud cycles like Earth's own. Lightning flashed in tropical storms, and winds swept across endless seas. But at some point, everything changed. Those oceans boiled, the sky thickened, and the water disappeared. Not underground, not into the planet, but into space. Venus's greatest mystery isn't how it became hot, it's how it lost its water. The echo of water. When Venus Express began analyzing the planet's atmosphere, one of its instruments, SPICAV, focused on ultraviolet light filtering through the upper layers. What it detected stunned scientists. Traces of hydrogen and deuterium, two isotopes of the same element, drifting into space. Hydrogen, the lightest of all atoms, escapes easily into the vacuum. Deuterium, which is heavier, lingers behind. On Venus, the ratio between the two is over 100 times greater than Earth's. This imbalance told a tragic story. Hydrogen had been stripped away by solar wind, leaving deuterium concentrated in the atmosphere. That could only mean one thing. Venus once had an enormous quantity of water, and most of it was gone. The math was devastating. Based on the isotope ratio, scientists estimate that Venus once held enough water to form an ocean at least 10 to 30 meters deep, possibly much more. Some models suggest entire seas comparable to the Atlantic. Now, all that remains are faint chemical ghosts, an echo of a lost ocean. The greenhouse spiral, the chain reaction that destroyed Venus's oceans, began with the planet's proximity to the Sun receiving almost double the solar radiation that Earth does. Its climate was always on a razor's edge. As sunlight heated the surface, water began to evaporate faster than rainfall could return it. The resulting water vapor trapped more heat, which in turn caused more evaporation, a self-reinforcing loop known as the moist greenhouse effect. At a critical threshold, the atmosphere became saturated. The oceans boiled, the sky filled with steam, and the planet crossed the boundary between stability and chaos. Once water vapor reached the upper atmosphere, it was exposed to ultraviolet radiation from the sun. The radiation broke the water molecules apart, a process called photodissociation, splitting them into hydrogen and oxygen. Without a magnetic field to shield it, Venus was defenseless. The solar wind, a continuous stream of charged particles, swept away the hydrogen atoms into interplanetary space. The heavier oxygen either bonded with carbon to form carbon dioxide or oxidized the surface rocks. The planet literally exhaled its oceans into the void. The desert sky today, Venus's atmosphere contains less than 0.002% water vapor, compared to Earth's average of about 1%. That's not just dry, it's desiccation at the molecular level. Even the sulfuric acid clouds, which shimmer in yellow-white layers, are parched. The droplets that make them up are composed of H2SO4, not H2O. When the Soviet Venera landers touched down in the 1970s and 80s, their instruments confirmed this profound dryness. They detected no trace of liquid on the surface, only pulverized basalt, rocks coated in sulfur, and a crushing atmosphere filled with carbon dioxide. It was as if the planet had been scrubbed clean of every molecule of water, its oceans baked out of existence. And yet, paradoxically, the clouds still swirl, the winds still howl, and the atmosphere remains in motion. It is a desert that behaves like a storm. Trapped beneath the clouds, Venus Express sought to understand how that atmosphere functions today, how it maintains its complex layering and dynamics despite being almost entirely devoid of water. The spacecraft's instruments detected distinct vertical structures, dense lower layers filled with carbon dioxide, an upper deck of sulfuric acid clouds, and, above that, a tenuous exosphere where gases escape into space. Between those layers lies a region known as the cold collar, circling the planet's poles. Temperatures here can drop as low as -170 degrees Celsius, -274 degrees Fahrenheit, colder than parts of Mars. This frigid belt exists because heat from the lower atmosphere struggles to rise past the cloud layers. It is one of the many contradictions of Venus, a planet hot enough to melt lead at its surface, yet cold enough to freeze carbon dioxide mere kilometers above it. These layers also act like a lid, trapping heat below. The result is a global oven sealed shut by its own chemistry, a greenhouse with no way to vent. The magnetic ghost Earth is protected by its magnetic field, a vast bubble generated by the spinning of its molten iron core. It shields us from solar wind and cosmic radiation, deflecting charged particles and preserving our atmosphere. Venus, however, lost that protection long ago. Its slow rotation prevents its core from churning fast enough to generate a magnetic dynamo. Instead, it has a magnetotail, a faint magnetic field induced by the interaction between its ionosphere and the solar wind. It's a ghost of a magnetic field, flickering and unstable. Venus expresses Aspera, for instrument measured this magnetotail stretching millions of kilometers into space. A shimmering plasma trail where charged particles leak away from the planet. Hydrogen, helium, oxygen, all drifting outward. It's a visual representation of loss. A stream of atoms escaping forever, the afterimage of vanished oceans. Dr. Stas Barabash, who led the experiment, put it simply, Venus is still losing its atmosphere today. We're watching a planet breathe out its history. A tale of two worlds, the contrast with Earth couldn't be more striking. Here, our magnetic field holds, our oceans persist, and our climate, though fragile, remains within habitable bounds. But the similarities are just as haunting. Venus's atmosphere once contained only trace amounts of carbon dioxide, just as ours does today. A few percentage points change in greenhouse gases was enough to tip its balance beyond recovery. When planetary scientists talk about climate thresholds, this is what they mean. There is a point, invisible but absolute, where a planet's systems shift irreversibly. Beyond that line, oceans boil, skies thicken, and heat becomes self-sustaining. Venus crossed that line eons ago. Earth is still walking toward it. The lessons of the lost ocean Venus Express gave humanity its clearest glimpse yet into the mechanics of a planetary collapse. It proved that a world can lose its oceans not through impact or catastrophe, but through slow, cumulative physics, the same physics that governs our own atmosphere. The mission's data showed that Venus continues to lose hydrogen and oxygen at measurable rates even today. Its atmosphere is not static. It's still evolving, still fading. Each atom that escapes carries away a fragment of the planet's past, a molecule that once might have been part of a wave, a cloud, or a raindrop. Venus reminds us that the sky is not permanent, can evaporate. The next phase of the Venus Express mission would look for clues in the planet's chemistry, complex molecules, strange spectral lines, and signals that could tell us what kind of reactions are still occurring high above the clouds. Some of those signatures were so unexpected that they reignited one of the oldest questions in astronomy. Could Venus still harbor the remnants of life, hiding in its atmosphere, surviving where everything else has perished? Part 6, Life in the Acid Sky. For centuries, Venus has embodied contradiction, beauty and destruction, light and fire, paradise and perdition. Even now, after decades of study, it refuses to give up its final secret, whether something might still be alive in its toxic sky. The idea sounds absurd. The surface of Venus is the definition of uninhabitable, 475 degrees Celsius 900 degrees Fahrenheit, 90 times Earth's pressure, and an atmosphere saturated with sulfuric acid. Any known organism would be crushed, boiled, and dissolved within seconds. And yet, a few dozen miles above that inferno, conditions change. There, in the middle cloud layer, between 48 and 60 kilometers up, the temperature drops to between 30 degrees Celsius and 70 degrees Celsius, and the pressure falls to values not unlike those on Earth's surface. It is still acidic, still harsh, but not impossible. This thin zone, just a few kilometers wide, is where the idea of life in the acid sky was born. The cloud zone of possibility in the 1960s, when the Soviet Venera missions sent the first data from Venus, a few bold scientists noticed something strange in the spectral readings. The light reflected from the planet's clouds wasn't uniform. Certain wavelengths, especially in the ultraviolet, were absorbed far more than expected. At first, the anomalies were dismissed as calibration errors. But later missions, including NASA's Pioneer Venus and Venus Express, confirmed that these UV-absorbing patches were real. They appeared as dark streaks or blotches, drifting across the cloud tops like enormous shadows, sometimes spanning hundreds of kilometers. No one could explain them. The clouds of Venus should be almost perfectly reflective, tiny droplets of sulfuric acid suspended in carbon dioxide gas. There should be no reason for dark patches to exist. Yet there they were, moving and changing shape, as if alive. The unknown absorber, the search for what caused these UV patches, became one of Venus Express's most curious investigations. Using its SPICAV and VERTIS instruments, the spacecraft measured how sunlight scattered through the clouds at various wavelengths. The results deepened the mystery. The absorbing material had a spectral signature unlike any known inorganic compound. It was not sulfur dioxide, not ferric chloride, not any of the typical minerals or gases expected in such an atmosphere. Whatever it was, it seemed to absorb ultraviolet light in the same way pigmented biological material does, compounds like chlorophyll or certain microbial photoreceptors. Dr. Sanjay Lamai, a planetary scientist at the University of Wisconsin, phrased the question delicately. We're not saying it is life, but we cannot say it's not. Earth's extremophiles, proof of the possible skeptics, once argued that no organism could survive in concentrated sulfuric acid. But life on Earth has a way of breaking rules. In volcanic craters, deep-sea vents, and acidic hot springs, biologists have discovered entire ecosystems thriving in conditions once thought sterile. Microbes known as acidophiles not only survive in acid, they depend on it. Acidithiobacillus ferrooxidans, for example, metabolizes sulfur and iron in environments with pH values close to zero. Other species, like Deinococcus radiodurans, can withstand radiation levels thousands of times higher than those that would kill a human. Some microbes even form aerosols, living suspended in clouds high above Earth's surface. If life can adapt to the acidic atmosphere of our own planet, could similar chemistry work on Venus? Astrobiologists began to imagine what a Venusian microbe might look like. It would need a tough outer shell, capable of resisting sulfuric acid, an energy source independent of sunlight, perhaps driven by chemical reactions with sulfur or iron, and the ability to remain buoyant in the dense air. A single drop of sulfuric acid cloud on Venus could potentially host billions of microscopic cells, if any exist. The phosphine signal in September 2020, years after Venus Express had completed its mission, a team of researchers announced a stunning discovery. Traces of phosphine, pH 3, detected in Venus's atmosphere. On Earth, phosphine is associated primarily with biological processes. It's produced by microbes that live in oxygen-free environments, such as swamps, sewage systems, and the guts of animals. Outside of biology, it forms only under extreme industrial or volcanic conditions. The detection came from the James Clerk Maxwell Telescope in Hawaii and was later confirmed by ALMA in Chile. The signal appeared strongest in the same altitude range as Venus's temperate cloud layer, right where the possibility of life had long been suspected. The scientific world erupted. Could this be the first indirect evidence of extraterrestrial life, floating, not crawling, in the sky of our nearest neighbor? Controversy and caution. The excitement was immediate, but so was the skepticism. Critics pointed out that phosphine can also form through volcanic outgassing, lightning, or photochemical reactions involving minerals and ultraviolet light. Others questioned whether the data were properly calibrated or whether sulfur dioxide had been misidentified as phosphine. Follow-up studies gave conflicting results, some confirming the presence of phosphine, others finding none. Dr. Jane Greaves, who led the discovery, urged patience. Whether it's biology or not, something strange is happening in Venus's atmosphere, and we need to go back to find out what. That statement captured the mood perfectly. The phosphine debate was not just about molecules, it was about mystery and the limits of our understanding. Lessons from the clouds. Even without definitive proof of life, Venus's atmosphere remains one of the most intriguing chemical environments ever studied. Venus Express detected hints of carbonyl sulfide, COS, a compound that, on Earth, is often produced by microbes and volcanoes alike. It also observed unexpected temperature inversions, variable sulfur dioxide levels, and unidentified aerosols that don't fit existing models. Each clue adds another layer to the puzzle. If life does exist there, it would not resemble anything we know. It would not breathe oxygen, drink water, or photosynthesize in sunlight. It might metabolize sulfuric acid itself, turning poison into sustenance. To imagine such life is not fantasy. It's chemistry extended to its logical extreme. A world that remembers whether alive or not. Venus's atmosphere behaves like something organic, dynamic, reactive, and constantly changing. Winds swirl through layers of cloud that shimmer in shifting hues. Lightning crackles through sulfuric storms. Invisible molecules drift upward, disintegrate under sunlight, and recombine in strange ways. It is an ecosystem of motion, if not of biology, a living laboratory for the limits of chemistry and physics. As Dr. Colin Wilson from the Venus Express team once said, "If there is no life there, the chemistry is doing a very good imitation of it." The next frontier, the possibility of life or something lifelike, has reignited interest in returning to Venus. NASA's Da Vinci Plus and Veritas missions, along with ESA's Envision, are set to launch in the coming decade. They will descend through the atmosphere, sampling gases, measuring isotopes, and mapping the surface with unprecedented precision. Some designs even propose aerobot probes, balloon-like laboratories that could drift through the temperate clouds for months, directly sampling the air where phosphine and the mysterious UV absorbers reside. For the first time, humanity may be able to test, not just guess, whether life ever took hold in Venus's sky. Venus, once dismissed as a dead world, may yet turn out to be a world that never truly died, only transformed. Perhaps its last refuge lies in the clouds, in microscopic survivors clinging to the faint line between chemistry and life. In the next part, we follow how these new discoveries reshape the scientific understanding of planetary habitability, how Venus's story is forcing scientists to redefine what it means for a planet to be alive. Part 7, Redefining Habitability for Generations. The word habitable conjured a simple image. A blue planet, oceans shimmering beneath a calm sun, air we could breathe, and temperatures that allowed liquid water to flow. That was the gold standard. It was Earth. But as scientists stared longer at Venus, the same size, the same origin, the same starting conditions, something shifted. The more they studied this infernal twin, the more they realized that habitability is not a state. It is a balance, a fleeting moment in a planet's long evolution. Venus forces humanity to rethink what it means for a world to be alive. The line between heaven and hell in the solar system, there is an invisible zone known as the habitable zone, or the Goldilocks region. It's the ring around a star where temperatures are just right for liquid water to exist on a planet's surface. Venus orbits at the inner edge of that zone. Earth sits comfortably in the middle. Mars, a little farther out, hugs the cold boundary. On paper, Venus should have been perfect, similar mass, abundant early water, a thick atmosphere to hold warmth. Yet a small difference in solar distance, only about 30% closer to the sun, pushed it past the threshold. In that extra sunlight lay a destiny. The difference between a world of oceans and a world of fire is measured not in millions of kilometers, but in fractions of equilibrium. Once the balance tipped, Venus's climate ran away from itself. The revelation is humbling. Habitability is not permanent. It's a phase, not a guarantee. The expanding definition of life's home as Venus fell from paradise. Scientists turned their gaze outward, to worlds colder, stranger, and darker, and began asking new questions. If Venus could once host water and maybe life, then could other, less Earth-like places also harbor the conditions for biology? That question changed the way astronomers approached exoplanets, worlds orbiting other stars. Before Venus Express, researchers defined the habitable zone purely by distance and temperature. But the lessons from Venus showed that a planet's atmosphere, rotation, and geological feedback are just as important as its location. A small change in greenhouse gas levels can push a planet inside or outside habitability, even within the same orbit. Venus became the archetype for the inner edge, the warning line beyond which the heat cannot be undone. Now, every time an exoplanet is discovered close to its star, astronomers ask, is this another Earth or another Venus? The Venus Zone in 2014, planetary scientist Dr. Stephen Kane coined a new term, the Venus Zone, a region around stars where planets are too hot to sustain oceans but not hot enough to lose their atmospheres entirely. These are worlds in transition, planets caught in the process of runaway greenhouse transformation. They are potential Venuses, brilliant, cloud-covered, reflecting light so intensely that they can outshine their stars in certain wavelengths. Ironically, these failed Earths may be easier to detect than habitable planets, because their thick clouds make them brighter. Venus, once an afterthought in planetary science, had become a cosmic template, the model by which we identify and understand other worlds on the brink. Lessons for Earth, but Venus's most important lesson is not about exoplanets. It's about home. For decades, climate scientists have used Venus as a cautionary tale, a glimpse of what happens when carbon dioxide runs unchecked. The planet's atmosphere is 96% CO2, trapping heat so effectively that its surface remains hotter than Mercury's, despite being twice as far from the Sun. On Earth, CO2 makes up less than 0.05% of the air. Yet our planet's climate is already shifting from small increases. Venus teaches us that feedback loops can be deadly. Once the oceans began to evaporate, water vapor, a greenhouse gas more powerful than carbon dioxide, trapped additional heat. That heat released even more CO2 from rocks, accelerating the spiral. The planet didn't just warm, it crossed a threshold where the feedback became irreversible. Climate physicist Dr. James Hansen, one of the first to model the greenhouse effect, once said, "If we push Earth's climate far enough, we don't need a runaway Venus scenario to destroy our world. A partial one will do." Venus is not merely a curiosity. It is a warning written in stone and cloud. The fragile balance for Venus expressed scientists, the mission became more than planetary exploration, it was an act of reflection. Every measurement, every spectrum was a mirror. They saw Earth's fragility through Venus's fire. In interviews, many of them described moments of quiet unease, realizing that the processes unfolding on Venus were not alien. They were the same physics at work on Earth, simply amplified and unrestrained. Our atmosphere, too, could thicken. Our oceans, too, could change chemistry. Our climate, too, depends on delicate balances we barely understand. Venus isn't warning us of what will happen. It's showing what can. The habitable moment, when viewed through this lens, habitability is not a binary state. It's a continuum, a spectrum stretching from sterile to alive to ruined. Earth, right now, exists in a fragile equilibrium. The same physical constants that sustain life, sunlight, pressure, chemistry, also contain the seeds of destruction. Planets, like living organisms, evolve. They age. They change atmosphere, temperature, and complexion. Some die in cold silence, others in fiery suffocation. Venus is a snapshot of a world past its prime, a reminder that even paradise has an expiration date. A new philosophy of worlds as humanity discovers more exoplanets each year. Some rocky, some gaseous, some orbiting dim red stars. The boundaries of habitability blur even further. Could a world wrapped in methane clouds harbor life in its haze? Could a planet buried beneath ice shelter oceans below? Could something alive exist in sulfuric acid skies? Venus answers all of these questions not with certainty, but with challenge. It tells us, don't define life by comfort. Don't assume Earth's chemistry is the only formula that works. If life ever arose on Venus, it did so not in defiance of nature, but as part of its grand experiment. And if it didn't, then Venus still teaches us how easily that experiment can fail. From twin to teacher, there's a strange poetry in this. Venus, the planet of love, the morning star, once symbolized beauty and creation. Today, it is our cautionary guide, a radiant corpse whispering the truths of climate and balance. It reminds us that the same processes that sustain life can also destroy it, and that the line between the two is vanishingly thin. For every thriving Earth, there may be countless Venuses scattered across the galaxy. Worlds that almost made it, worlds that shone briefly before succumbing to their own heat. To study Venus is to confront our reflection in time, to see where we came from and where we might one day go. In the next chapter, the story of Venus Express deepens. The spacecraft will turn its gaze toward the planet's polar regions, uncovering vast swirling vortices, double-eyed storms that behave like cosmic engines, churning heat and gas through the atmosphere in ways never seen before. Through them, scientists will glimpse the final piece of the puzzle: how Venus's atmosphere moves, breathes, and perhaps still evolves today. Part 8. The Eye of the Storm. Every planet has a rhythm, a pulse of weather and rotation that defines its climate. On Earth, that rhythm is predictable. Air rises at the equator, sinks at the poles, and dances in the steady swirl of jet streams. On Venus, that rhythm is chaos. When Venus Express focused its instruments on the planet's poles, scientists expected to find calm, regions of cold air and descending currents, perhaps frozen stability. Instead, they found storms the size of continents. Each pole of Venus hosts a colossal vortex, a whirlpool of gas and cloud that stretches more than 2,000 kilometers across. These vortices are not stable eye-like hurricanes. They twist, fold, and mutate into new shapes every few days. At times, they resemble enormous double eyes. At others, they form elongated S-shapes that ripple across the pole like a heartbeat. What drives them remains one of the planet's most profound mysteries. A swirling engine at the pole. When Venus Express began its polar observations in 2006, it captured a series of thermal infrared images that stunned the mission team. The South Polar Vortex, visible only in heat signatures, glowed like a spiral galaxy, two bright eyes orbiting a central darkness. Each eye was roughly the size of the state of Texas. Dr. Giuseppe Piccioni, one of the mission's lead investigators, described his first reaction. It was hypnotic. The vortex didn't stay still. Every time we looked, it changed shape. It was as if the planet's atmosphere were alive, breathing. Unlike Earth's hurricanes, which are powered by warm ocean water, Venus's polar vortices are born from pure atmospheric dynamics. As the planet's superrotating winds race around the equator, they pile up near the poles, where the air must descend. The Coriolis effect, though weak on such a slow-spinning world, twists these descending currents into whirlpools. But the strange part isn't their existence. It's their complexity. The South Polar Vortex often splits into two cores that orbit each other, a phenomenon seen nowhere else in the solar system. The entire system oscillates, migrating from one pole to another like a wandering storm. The cold and the fire. Venus's poles are paradoxes of temperature. While the surface below is hot enough to melt metal, the atmosphere above can plummet to minus 170 degrees Celsius, minus 274 degrees Fahrenheit in places. The vortex acts as a refrigerator, pulling hot air upward and releasing infrared radiation into space. It's one of the few mechanisms through which the planet can shed heat. In a sense, the vortices are Venus's only relief valves, the last breath of a world that can no longer cool itself. Venus Express's instruments traced the vertical structure of these storms from top to bottom. At high altitudes, the air moves at hurricane speeds, 300 to 400 kilometers per hour, 180 to 250 miles per hour. While deeper down, it slows into dense, spiraling currents that churn like molten glass. The thermal contrast is staggering. Layers of air separated by over 200 degrees Celsius, stacked like the layers of an inverted oven. No other planet combines such extreme vertical gradients with such slow rotation. It's as if the entire atmosphere is locked in an endless struggle between pressure and motion, between heat rising and gravity pulling it back down. The double-edged spiral, one of the most fascinating features of the Venusian vortices, is their double structure. Unlike a hurricane on Earth, which forms a single clear eye, Venus's storms often display two rotating centers, each orbiting the other in a slow, graceful dance. Venus Express watched these eyes drift apart, merge, and reform again, their motion resembling a binary star system. This strange configuration arises from the way Venus's atmosphere moves not in circles, but in waves. Energy from the equator propagates toward the poles in massive standing waves that twist the air into complex patterns. Dr. David Lewis of the University of Lisbon called it a vortex with a mind of its own. In simulations, when scientists replicated Venus's slow spin and thick air, they found that similar double vortices emerged spontaneously, self-organizing patterns in turbulent flow. On Venus, such structures may persist for centuries, moving heat and gas between layers in ways we are only beginning to understand. The planet's great conveyor, the discovery of these vortices, transformed the scientific picture of Venus's climate. Before Venus Express, scientists believed the atmosphere circulated vertically, from equator to pole, surface to sky, in a simple loop. The new data revealed something far more dynamic, a global conveyor belt, with multiple cells of air moving in opposite directions, exchanging heat and momentum through the vortex engines at each pole. This system may be the key to Venus's superrotation, the mysterious phenomenon where the atmosphere spins 60 times faster than the surface. Imagine a giant planetary gear. As the equatorial winds accelerate, they feed energy into the polar vortices. The vortices, in turn, redistribute that energy back into the mid-latitudes, sustaining the entire circulation. It's a feedback loop of motion, self-sustaining, without oceans or seasons, only heat and gas. The heartbeat of a planet over the course of its mission, Venus Express mapped how the vortices changed over time. Some months they appeared circular and calm. Other times, they stretched into elongated, pulsing shapes, hinting at deeper changes in the atmosphere below. These oscillations are not random. They follow cycles tied to the planet's day-night rhythm, and its slow rotation relative to the Sun. Venus's day lasts 243 Earth days, but its atmosphere completes its journey around the planet every 4. This mismatch creates constant tension, like gears grinding at different speeds. To planetary scientists, this is more than meteorology, it's the heartbeat of a world. Every pulse of the vortex, every fluctuation in temperature, carries information about how the entire planet breathes. Patterns in the chaos. To analyze the storms, researchers used thermal imaging to build time-lapse maps of Venus's poles. When played in sequence, the data revealed something hauntingly familiar. The vortex appeared to rotate and oscillate in quasi-periodic patterns, reminiscent of Earth's own El Niño cycles, though magnified beyond recognition. If Venus once had oceans, these patterns might have been its equivalent of global weather systems, cycles that once governed rain, storms, and wind, now fossilized in the air. It's as though the planet remembers. The silent symmetry in ultraviolet light. The poles of Venus glow faintly, surrounded by rippling waves of cloud. In infrared, they burn with inner heat. Between the two spectrums lies an eerie symmetry, a perfect circular storm at each end of the world, rotating in opposite directions. One turns clockwise, the other counterclockwise, two mirrors, two halves of a global engine. They are the last great symbols of Venus's balance, a balance now ruled by extremes. Dr. Håkan Svedum, project scientist for Venus Express, summarized it poignantly. The poles are the lungs of Venus. Through them, the planet breathes heat in and out. But the air it exhales is never cool. It is only less hot. The lesson in motion. The vortices of Venus are more than meteorological curiosities. They are windows into a kind of planetary evolution that may be common across the galaxy. Slow rotators with thick atmospheres, trapped between runaway heat and perpetual motion. Understanding them helps scientists model not only Venus, but exoplanets orbiting close to their stars, worlds where heat and turbulence reign, and yet order still emerges from chaos. Venus shows that even in the most hostile conditions, physics finds patterns. It builds order from turbulence, symmetry from violence. That principle, perhaps, is the deepest form of habitability, not biological but mathematical. The cosmos itself seeks balance. In the next part of this story, the focus shifts once more, from atmosphere to light. Venus Express begins to observe night glow, the faint emission of photons in the planet's dark side, revealing a world that literally glows in the dark. These lights, flickering above the inferno, may hold the key to understanding how the planet's chemistry continues to evolve even now. Part 9. The planet that glows in the dark, in the dead silence of space. Venus looks serene, a smooth, featureless disk of ivory light. But when night falls on its far side, something strange begins to happen. The planet starts to glow, not with reflected sunlight or volcanic fire, but with an eerie, greenish radiance that shimmers in invisible wavelengths. It is a light born not of life, but of chemistry, a planet breathing photons into the dark. This phenomenon, known as night glow, was first hinted at by early Soviet probes in the 1980s. Yet it was Venus Express that finally revealed it in haunting detail, transforming what was once a curiosity into one of the most important clues to the planet's ongoing evolution. The breath of the night side, unlike Earth, Venus has no true night. Its thick atmosphere scatters sunlight so completely that even on the dark side, there is a faint, reddish twilight that never disappears. But beneath that dim haze, high in the upper atmosphere, around 100 kilometers above the surface, Venus Express detected a faint emission line in the visible spectrum, a glow produced by oxygen atoms recombining into molecules. Here's what happens. During the day, ultraviolet radiation from the sun tears apart molecules of carbon dioxide and oxygen. As the superrotating winds sweep these excited atoms to the planet's night side, they cool and recombine, releasing energy in the form of light. It is, quite literally, the planet exhaling its sunlight. The glow is subtle, far dimmer than Earth's auroras, but constant. In infrared, it flickers like slow lightning. In ultraviolet, it pulses like a heartbeat. Dr. Jean-Louis Berthaud, principal investigator for Venus Express's SPICAV spectrometer, called it the planet's chemical respiration. You can think of it, he said, as the visible rhythm of a living chemistry, an atmosphere still reacting, still alive. The chemistry of light night glow on Venus is not a single color, but a complex symphony of emissions. The brightest line comes from atomic oxygen at a wavelength of 1.27 micrometers, a ghostly green invisible to the naked eye. But there are others, faint red and blue lines from nitric oxide, hydroxyl, and sulfur compounds. Each color tells a story about what's happening in the atmosphere. By mapping the intensity and distribution of the glow, Venus Express was able to trace the flow of gases across the planet. The patterns revealed that Venus's upper atmosphere behaves like a conveyor belt. Gases rise at the equator, travel toward the poles, then descend, shedding their excess energy as light. In this sense, the glow isn't just beautiful, it's a diagnostic tool. It shows how heat and chemistry move through the sky of a world that should have long ago gone still. The moving lights, one of the mission's most surprising discoveries, was that the glow moves. At first, scientists expected a steady, even emission. But Venus Express observed dramatic variations, patches of brightness that shifted from one hemisphere to the other over hours or days. Sometimes, the glow would flare suddenly, like a lightning storm. Other times, it would fade almost completely, leaving vast swaths of the night side in darkness. This variability hinted at deeper turbulence, perhaps waves of energy traveling upward from lower layers, or bursts of recombination triggered by shifting winds. Even more intriguing, the glow's intensity correlated with solar activity. During solar flares, when the sun bombarded Venus with charged particles, the planet's night glow brightened, as if responding in kind. It was a reminder that Venus, though smothered in clouds, remains intimately connected to its star, its atmosphere dancing to the sun's magnetic rhythm. The lightning question Venus Express's instruments also recorded short, intense bursts of light within the glow, possible evidence of lightning. For decades, scientists debated whether Venus experiences electrical storms. The Soviet Venera and American Pioneer Venus missions had detected strange radio pulses, but no one could confirm them visually. The thick clouds made optical observation nearly impossible. Venus Express changed that. Using its magnetometer and plasma sensors, it picked up electromagnetic signatures consistent with lightning discharges, occurring tens of kilometers above the surface, in the same regions where the night glow flickers most intensely. If true, it means Venus is not only volcanically and chemically active, but electrically alive as well. A planet where the sky still crackles with power. Lightning in sulfuric acid clouds would be unlike anything on Earth. It would not spark between water droplets, but between acid particles and CO2 gas. The energy of each strike could reach hundreds of megajoules, generating exotic molecules like nitrogen oxides and carbonyl sulfide, compounds central to both volcanic and biological chemistry. Lightning, night glow, and atmospheric chemistry. 3 layers of interaction, all feeding one another in a cycle that has no true beginning or end. A planet that still breathes for planetary scientists. The night glow offered a revelation. It proved that Venus's atmosphere is not stagnant. It circulates, reacts, and changes continuously. Despite its age and apparent lifelessness, the planet is still active. The night side, once thought to be dead and quiet, turned out to be a place of constant transformation. In one series of observations, Venus Express captured a global wave, an oscillation of light and temperature sweeping from pole to pole. This wave traveled too slowly to be wind-driven, suggesting it might be a planetary-scale resonance, a kind of standing vibration in the atmosphere itself. Some compared it to the ringing of a bell. Venus, it seems, hums in its own light. The ghost of a magnetic field night glow is also linked to another subtle phenomenon: Venus's induced magnetosphere. Because the planet lacks a natural magnetic field, the solar wind penetrates deeply into its atmosphere, creating electric currents that interact with charged particles. These interactions can accelerate electrons, which then collide with molecules, producing flashes of light similar to Earth's aurora, but spread thin across the entire night side. In other words, Venus doesn't just glow from chemistry, it glows from electricity. The planet's magnetotail, a long plume of ionized gas streaming away from the sun, carries this light into space like a comet's faint trace. To passing spacecraft, Venus appears not only as a planet, but as a torch, leaking photons and plasma into the void. The poetry of decay. To see Venus's night glow is to witness both death and persistence. The light exists because the atmosphere is constantly torn apart by sunlight, its molecules broken and remade, its gases recycled and lost. The glow is the signature of decay, yet it gives the planet beauty beyond any lifeless rock. Venus glows because it is still reacting, still fighting entropy, still moving energy from day to night, light to dark. It is a slow-burning candle, powered by its own ruin. A living chemistry Dr. Colin Wilson, a member of the Venus Express science team, once described the glow as the closest thing to a heartbeat you can see from 40 million kilometers away. He wasn't speaking metaphorically. Each pulse of light represents the recombination of oxygen atoms that once belonged to water molecules, remnants of the oceans that boiled away billions of years ago. Every flicker is a memory, a chemical echo of rain that no longer falls. In that sense, Venus's night glow is more than a spectacle. It's a record of loss written in photons. It is the ghost of an ocean, still shining in the dark. In the next part, Venus Express begins to observe something even more unexpected: gravitational and atmospheric waves rippling across the cloud tops. Evidence that the planet's hidden mountains, far below the clouds, still shape the sky. These invisible fingerprints will reveal how Venus's buried geology continues to influence its atmosphere, proving that even beneath its suffocating shroud, the planet's surface still speaks. Part 10. The mountains beneath the clouds. To most telescopes, Venus looks smooth, a perfect sphere wrapped in cloud, its surface hidden beneath an impenetrable veil. For centuries, that veil was complete. No mountain, no crater, no valley could be seen. But through radar eyes and orbiting instruments, we have learned that Venus is not smooth at all. Beneath those clouds lies a world of colossal mountains, ridges, and volcanic plains, sculpted by fire and time. And though those mountains have been buried for 500 million years, their influence still reaches the skies. The Venus Express mission uncovered something extraordinary. The surface of Venus still shapes its atmosphere. Even now, long after the planet's last cataclysmic resurfacing, its hidden topography sends waves rippling upward, waves that rise through the thick air and manifest as ghostly patterns in the clouds above. It is as if the mountains themselves still breathe. The Hidden Face, the Soviet Venera 15 and 16 missions of the 1980s first mapped Venus's northern hemisphere using radar. Later, NASA's Magellan spacecraft, orbiting from 1990 to 1994, revealed the entire planet in stunning detail. What Magellan saw was a landscape both alien and hauntingly familiar. There were mountain ranges like Maxwell Montes, towering 11 kilometers high, taller than Mount Everest. There were vast highland plateaus such as Ishtar Terra and Aphrodite Terra, and sprawling plains of hardened lava that stretched for thousands of kilometers. But the radar maps told only half the story. Venus Express, orbiting more than a decade later, provided the other half, how that terrain affects the air above it. Using its visible and infrared thermal imaging spectrometer VIRTIS, the spacecraft observed long, wave-like structures on the upper cloud decks, patterns so massive they could only be explained by something far below. These weren't ordinary clouds. They were atmospheric gravity waves, the atmospheric equivalent of ripples on water, caused when winds flow over mountains and push air upward. For the first time, scientists realized Venus's invisible mountains are still sculpting its sky. The monster wave of Aphrodite Terra in late 2015, Japanese scientists using the Akatsuki spacecraft, which succeeded Venus Express, confirmed one of the most spectacular atmospheric features ever seen on any planet. A single, stationary wave more than 10,000 kilometers long, nearly the size of the continental United States. Venus Express had hinted at such phenomena years earlier, but Akatsuki's discovery validated what the ESA mission first detected: that the surface and atmosphere of Venus are locked in a delicate, dynamic relationship. This particular wave hovered above Aphrodite Terra, one of the planet's largest highland regions. Despite the hurricane-speed winds that circle the planet every 4 days, the wave remained fixed in place, immovable. That immobility was the clue. It could only be caused by airflow colliding with the terrain below, forcing air upward and generating standing waves that reached all the way to the upper atmosphere. Imagine wind flowing over mountains on Earth. As it rises, it cools and condenses, forming repeating ripples of cloud known as lenticular formations. On Venus, the same process happens, but on a global scale with waves that stretch thousands of miles and rise up to 20 kilometers high. These waves reveal a startling truth. Even though we can't see the surface directly, Venus's mountains are still shaping the sky every single day. The planet that remembers its shape in the dense atmosphere of Venus, sound and motion travel differently. Air is so thick it behaves almost like a fluid. When winds strike a mountain range, they don't simply pass over. It's as if the entire lower atmosphere flexes and bends, transmitting pressure waves upward. Venus Express detected these waves as subtle changes in temperature and air density. When plotted as altitude profiles, they formed oscillating patterns like heartbeat readings, repeating every few kilometers. The waves move vertically at speeds of only a few meters per second, but they carry enormous energy. Some scientists estimate that a single planetary scale wave could contain as much kinetic energy as all the weather systems on Earth combined. These waves, rising and breaking, may even help maintain superrotation by transferring angular momentum from the surface upward, feeding the fast-moving winds that race around the planet. In this way, the terrain acts as the unseen engine of the atmosphere. Venus, though geologically stagnant, is aerodynamically alive. The conversation between rock and sky, this discovery blurs the boundary between geology and meteorology. On Venus, the two are inseparable. Dr. Stephen Lebenois, an atmospheric modeler at the Laboratoire de Météorologie Dynamique in Paris, described it this way: Venus doesn't have plate tectonics. It doesn't have oceans. But it has an atmosphere so thick that it carries the memory of the land beneath it. The air remembers where the mountains are. that memory can be seen even from space. In ultraviolet light, the tops of Venus's clouds display faint, repeating bands, parallel streaks that match the contours of the terrain below. It is an astonishing concept. A planet whose atmosphere behaves like a fluid sheet stretched over invisible hills, rippling and wrinkling as it flows. The pulse of the highlands among the most studied regions influenced by these waves is Ishtar Terra, a vast highland plateau near the planet's north pole. Here, Venus Express observed rhythmic oscillations in air temperature, small but consistent pulses that rose and fell every few hours. These temperature waves are thought to be Lee waves, created as high-speed winds tumble down the slopes of Maxwell Montes. As they propagate upward, they interact with chemical layers, creating regions of localized heating and cooling that influence cloud formation. To the naked eye, these effects are invisible, but in infrared, the clouds above Ishtar Terra shimmer like the surface of disturbed water. Venus Express scientists nicknamed the region the planet's pulse point. The stillness beneath what makes this all the more remarkable is that the mountains themselves no longer move. Venus's crust is stagnant, locked in place by heat and pressure. There are no shifting plates, no rising continents, no tectonic renewal. And yet, in the motionless silence below, the ghost of movement persists. The mountains, frozen in stone, still shape the chaos above. It's a quiet form of communication, a geophysical dialogue between rock and air. Venus has become a planet where stillness creates motion, where buried landscapes write invisible patterns across the sky. The deeper implication this interplay between surface and atmosphere changes how scientists think about planets. On Earth, tectonics and weather interact constantly, but separately. Volcanoes emit gases, mountains affect rainfall, and erosion shapes valleys. On Venus, those boundaries dissolve. There is no erosion, no rainfall, only heat and air. The atmosphere itself becomes the sculptor, and the surface the mold. It suggests that even on planets without oceans or plate tectonics, topography still matters. For exoplanets shrouded in thick atmospheres, their internal landscapes might reveal themselves through similar atmospheric waves, fingerprints of hidden continents, mountains, or volcanoes. Venus teaches us to listen to a planet's clouds if we want to understand its ground. The whisper of the mountains when Venus Express transmitted its final datasets. Some of its last images showed faint, undulating lines across the night side of the planet, cloud waves frozen in motion. They were not dramatic, not bright, just subtle hints of rhythm amid the sulfuric haze. But to the scientists who spent years studying them, those lines were everything. They were proof that even a planet smothered in acid and fire still responds to the shape of its heart. Venus, long thought to be silent, is in constant conversation with itself. The mountains whisper upward. The sky answers with waves. In the next part, the focus widens once again, from the planet's internal dynamics to its global interactions. As the Venus Express mission enters its later years, the spacecraft begins to detect patterns linking Venus's atmosphere to solar activity, cosmic radiation, and even potential magnetic resonances that echo far beyond its orbit. What scientists find next suggests that Venus is not just a victim of the Sun's fury, it's an active participant in the solar system's magnetic web. Part 11. The Sun's shadow on Venus. Every world in the solar system dances to the Sun's rhythm, but none more dramatically than Venus. It is a planet locked in permanent tension with its star, a world scorched and sculpted by solar fire. When Venus Express turned its sensors toward the upper layers of the atmosphere, scientists discovered that the Sun doesn't merely illuminate Venus, it controls it. Solar storms, magnetic gusts, and high-energy radiation constantly bombard the planet, altering its chemistry, stripping its gases, and even stirring its winds. In the sunlight, Venus burns. In the shadow, it glows. And between the two, it breathes to the Sun's pulse. The solar whip. Venus orbits closer to the Sun than any other planet except Mercury. At that range, it experiences solar radiation levels almost twice those of Earth, and its atmosphere acts like a gigantic absorber, a mirror that reflects visible light but traps infrared heat. However, light is only part of the story. Venus is also struck by the solar wind, a stream of charged particles, mostly electrons and protons, that flows outward from the Sun at 400 kilometers per second. Earth's magnetic field deflects most of these particles, forming a protective bubble called the magnetosphere. Venus has no such shield. Its core spins too slowly to generate a magnetic field of its own. Instead, the solar wind plows directly into the planet's atmosphere, carving an induced magnetosphere in the process. This interaction is violent and continuous. During solar flares and coronal mass ejections, when the Sun spews billions of tons of plasma, Venus takes the full hit. The upper layers of its atmosphere, ionized and stripped of electrons, flare with ultraviolet and X-ray emissions. At times, these bursts increase the planet's atmospheric loss rate by a factor of 10. It's as though the Sun periodically reaches out and tears away pieces of Venus's sky. The magnetic mirage, even without a true magnetic field, Venus still generates a kind of electromagnetic shadow. When the solar wind crashes into its atmosphere, it creates a bow shock, a massive, curved shock wave that wraps around the planet like a comet's head. Behind it trails a long magnetotail, extending millions of kilometers into space, pointing away from the Sun. Venus expresses aspera, for instrument short for analyzer of space plasmas and energetic atoms, mapped the structure in exquisite detail. It revealed streams of charged particles flowing along invisible lines, guided by the planet's induced magnetic currents. The magnetotail, to scientists' surprise, occasionally reconnects with the solar magnetic field, releasing bursts of energy similar to solar flares. These reconnection events launch plasma waves downstream, like ripples in an invisible ocean. Dr. Stas Barabash, principal investigator for Aspera 4, described it poetically. Venus has no magnetic heart, yet it wears the Sun's magnetic cloak. It's not a shield, it's a leash. The stripped atmosphere every second, Venus loses a small portion of its atmosphere to space. Venus Express measured this loss precisely, roughly 2 kilograms of gas per second, mostly hydrogen and oxygen ions. That may sound trivial, but over billions of years, it adds up to oceans. The spacecraft detected plumes of escaping particles streaming from the night side of the planet, forming a diffuse tail that stretches far beyond Venus's orbit. In ultraviolet light, this tail glows faintly, a comet-like trail of planetary breath. Each escaping atom tells the same story. The Sun is slowly unmaking its creation. On Earth, the magnetic field prevents this kind of erosion, but Venus has no such defense. What we see today, a dense carbon dioxide atmosphere, is what remains after most of the lighter elements have been stripped away. The hydrogen that once bound with oxygen to form water is long gone, stolen by the Sun and carried into interplanetary space. In a sense, the oceans of Venus now orbit the Sun. The solar heartbeat Venus Express also found that the planet's atmosphere responds directly to solar cycles. Every 11 years, the Sun's magnetic field flips, its poles reverse, and solar activity waxes and wanes. On Earth, this cycle influences auroras and satellite radiation. On Venus, it changes the entire chemistry of the sky. During solar maximums, the increased ultraviolet radiation triggers photochemical reactions that alter the balance of sulfur compounds in the clouds. The haze thickens. The reflectivity of the planet changes. When the Sun quiets, the clouds thin and the upper atmosphere cools. In other words, Venus's appearance literally beats to the rhythm of the Sun. The planet is not just heated by its star, it is modulated by it, as if the two are locked in a feedback loop billions of years old. The electric planet, one of Venus Express's most surprising findings, came from measurements of electrical currents in the ionosphere. These currents form when the solar wind's magnetic field interacts with charged particles in the upper atmosphere. At certain times, the currents intensified dramatically, so much that they generated transient magnetic fields strong enough to be detected hundreds of kilometers away. These are not random fluctuations. They appear in cycles, tied to the same solar events that trigger the planet's night glow and lightning. It's possible that these electromagnetic surges cascade downward, influencing cloud formation and even wind speed in the lower atmosphere. Some scientists have speculated that the planet's superrotation, its atmosphere spinning 60 times faster than its surface, might be partly sustained by this invisible electrical coupling to the Sun. In effect, Venus's climate may not be fully internal. It may be partially driven from space. The shadow of the star to study Venus is to study the Sun's power at its most intimate. The planet's day side blazes under relentless radiation, while its night side glows from the recombination of atoms torn apart by daylight. Every molecule, every photon, is a record of solar violence and atmospheric endurance. Even its clouds, those thick curtains of sulfuric acid, are products of that tension. They form when sulfur dioxide from the surface reacts with sunlight and trace water vapor, creating aerosols that both shield and suffocate the planet. Venus has become a mirror, reflecting the energy of its parent star so completely that from space, it shines brighter than anything else in the night sky. Yet beneath that brightness lies total destruction. The bringer of light has become the keeper of darkness. A planet at the edge. As the data from Venus Express accumulated, scientists began to see the planet not just as an isolated system, but as part of a broader network, the heliosphere, the magnetic bubble that encompasses the entire solar system. Venus is not passive within that network. It interacts, responds, and sometimes even resonates. During major solar storms, ripples in the Sun's magnetic field pass through Venus, then continue outward toward Earth and Mars. By studying how Venus's atmosphere reacts, scientists can predict how these same storms might affect other planets and our own satellites. Venus has become, unexpectedly, a space weather sentinel. Its suffering offers protection to others. The eternal connection despite everything the Sun has taken from Venus, its oceans, its air, perhaps even its chance at life, the two remain locked together, endlessly exchanging energy. Every photon that strikes the planet is absorbed, scattered, or re-emitted. Every ion that escapes carries a story of creation and loss. The Sun is both Venus's destroyer and its lifeline. Without its energy, the planet would be dark and dead. Because of it, Venus still glows, still moves, still burns, still teaches. The connection is not cruel. It is cosmic. In the next part, Venus Express will confront its final frontier, its own descent. After nearly a decade orbiting the planet, the spacecraft's fuel begins to run out. Its mission enters its last phase, a controlled fall into the upper atmosphere. As it plunges toward the planet it studied for so long, the probe sends its last messages home, offering one final look into the heart of the inferno. Part 12, The Descent of Venus Express. By late 2014, after more than 8 years orbiting the planet, Venus Express was running out of fuel. Its solar panels still gleamed in the faint yellow light of the inner solar system, but the propellant that kept it stable, tiny bursts of hydrazine that fought the relentless drag of Venus's atmosphere, was nearly gone. Every orbit brought the spacecraft closer to the edge of survival. For the scientists and engineers who had guided it since launch, the mission's end was inevitable. But no one wanted to simply switch it off. They decided instead to give Venus Express a final purpose, to dive deliberately into the planet it had studied so long. They called it the aerobraking experiment, a poetic term for a controlled fall into an alien sky. The last orbits in May 2014, ESA Mission Control in Darmstadt, Germany, uploaded a final sequence of commands. The spacecraft's orbit was lowered gradually, from its usual apogee of 66,000 kilometers down to just 130 kilometers above the surface, low enough to feel the faint, invisible fingers of Venus's atmosphere brushing against it. Each pass took Venus Express deeper into the drag. The spacecraft began to heat up. Its solar arrays flexed and vibrated as atmospheric molecules struck them at speeds of 11 kilometers per second. For the first time, a human-made object was surfing the edge of another planet's atmosphere. The engineers monitored it closely. The data they received was invaluable measurements of air density, wind speed, and temperature at altitudes never before explored. But the risk was enormous. At any moment, A miscalculation could cause the spacecraft to tumble, burn, or vanish into the pressure below. As the orbits tightened, the communication signals grew faint. Delays increased. The data came in bursts, as if the probe itself were breathing more slowly. It was like listening to a heartbeat fade, recalled Dr. Hawkinsvedam, the mission's project scientist. Touching the edge of hell at its lowest point, Venus Express dipped into the atmosphere at 129 kilometers, a region no spacecraft had ever survived for more than a few minutes. The air here is thin by Venusian standards, but still 10 times denser than Earth's upper atmosphere. The heat was intense. The spacecraft's thermal sensors recorded rising temperatures across its panels, climbing past safety thresholds. Yet it held. Each time it passed through perigee, the craft slowed slightly, its orbit decaying just a bit more. Then it would swing back out to the safety of space, catching its breath before the next plunge. Over dozens of these descents, Venus Express mapped the transition zone, the mysterious region where the planet's dense lower atmosphere gives way to the plasma of space. It revealed how charged particles from the sun mix with carbon dioxide molecules, how solar radiation stirs turbulence, how heat flows upward like a slow-burning tide. The spacecraft, in its final weeks, gave humanity its first real measurements of the border of hell. The whispering planet, the closer it fell, the more the planet seemed to speak. Its sensors detected waves of pressure rippling upward, acoustic vibrations caused by the same atmospheric tides that move the clouds above the mountains. Temperature gradients spiked unpredictably. Trace chemical compounds fluctuated wildly, suggesting pockets of unknown gases. At one point, Venus Express detected an unexpected surge of oxygen ions, likely remnants of the planet's lost water being stripped away by the solar wind. It was as if the ghost of Venus's ocean reached up to brush against the intruder. It felt, one scientist later wrote, as though the planet wanted to tell us one last secret. But there was little time left to listen. The silence that follows by late November 2014, contact became erratic. The spacecraft's thrusters, exhausted, could no longer adjust its orbit. Mission Control watched as the telemetry signals grew weaker, then stopped. On November 28, ESA officially declared Venus Express lost. No one saw its final moments, but the team had simulated them countless times. As the probe descended below 120 kilometers, the heat would have climbed above 1,200 degrees Celsius. The solar panels would have vaporized first, then the instruments, then the titanium frame. In less than a minute, the spacecraft would have disintegrated completely, becoming part of the planet's atmosphere. It was, in a way, a fitting end. The explorer that had spent years studying Venus's skies had finally joined them. The legacy in the data, though Venus Express is gone, its discoveries endure. Over 8 years, it sent back nearly 20 terabytes of data, enough to fill every shelf of a small library with new insights about our sister world. From those signals came evidence of active volcanism, suggesting the planet may still be geologically alive. Atmospheric escape, revealing how Venus continues to lose its gases to space. Superrotation and polar vortices, mapping winds faster than any on Earth. Night glow and lightning, showing the planet's atmosphere still moves and burns. And chemical mysteries, sulfur cycles, UV absorbers, and traces of phosphine, that may yet redefine where life can exist. Each of these findings built a bridge between Venus and Earth, between the known and the unknown. The human moment in December 2014, a small ceremony was held at ESA headquarters. The engineers, scientists, and flight controllers who had guided the mission gathered in silence as a final transmission was played. The last faint carrier tone from Venus Express, recorded just before contact, was lost. It was little more than static, a soft hiss fading into nothing. But for those who had spent a decade listening to that voice, it felt like saying goodbye to a living thing. One of the flight engineers wrote in her notebook, "Venus kept our machine longer than we expected. Maybe she was curious about us too." There was laughter and a few quiet tears. The data lives on years later, researchers still mine the mission archives. Every so often, a new paper appears. A discovery hidden in the noise, a pattern no one noticed before. Venus, through Venus Express, continues to speak. ESA's next mission, Envision, is scheduled for the early 2030s. It will carry radar and spectrometers far more advanced than Magellan's or Venus Expresses, capable of mapping the surface with unprecedented clarity. NASA, too, plans to return with Da Vinci Plus, a probe that will plunge through the atmosphere, sampling gases as it falls, and Veritas, which will image the planet in 3D. In every sense, Venus Express opened the door. It proved that even the most hostile world can be reached, studied, and understood. The descent's meaning the fall of Venus Express was not an end but a transformation. In death, it joined the very system it studied, a small fragment of metal and circuitry absorbed by the same currents of wind and heat that had fascinated it for years. Somewhere, far beneath the clouds, its atoms now drift in the dense, carbon-rich air, becoming, in the most literal sense, part of Venus. That thought comforts the scientists who sent it there. Because, as Dr. Colin Wilson once said, to study a world like Venus, you must be prepared to lose something to it. But what it gives back is greater than what it takes. In the next part, the story widens to the cosmic scale, the legacy of Venus Express not just as a mission, but as a message. Its findings reshaped our understanding of planetary evolution, climate, and fate. And as Earth warms under its own greenhouse sky, Venus's reflection grows clearer every year. Part 13, The Mirror of Earth, the story of Venus Express is not just the story of another planet. It's the story of us. For in Venus, humanity sees its own reflection. A world that began almost the same as Earth and ended in fire. The spacecraft's final transmissions, drifting through the void before being swallowed by the clouds, carried more than scientific data. They carried a message, a warning written in heat, pressure, and time. Because Venus was once like Earth. And if the data are right, Earth could one day become like Venus. The twin that turned billions of years ago, Venus and Earth were near equals. Both formed from the same cosmic dust, orbiting within the Sun's habitable zone. Both likely had oceans, clouds, and rain. But where Earth found balance, Venus fell into runaway change. Venus Express showed us how that transformation began. Sunlight heated the oceans, more water evaporated, and water vapor, an efficient greenhouse gas, trapped even more heat. As the temperature climbed, the oceans began to boil, releasing yet more vapor. The process accelerated until the planet's surface reached the point of no return. The oceans disappeared, the atmosphere thickened with carbon dioxide, and the surface baked at 470 degrees Celsius 880 degrees Fahrenheit. The transformation was irreversible. Venus became a world where the sky kills. Today, its clouds reflect sunlight with dazzling brilliance, making it one of the brightest objects in our sky. But beneath that radiance lies a lesson written in catastrophe. The greenhouse mirror for scientists studying climate change, Venus is more than an astronomical curiosity. It's the worst-case scenario. What Venus Express confirmed was that the planet's heat trap isn't just caused by proximity to the sun. It's caused by a feedback loop of greenhouse gases and atmospheric chemistry. A feedback loop that once started cannot be stopped. Carbon dioxide on Venus makes up 96.5% of its atmosphere. On Earth, it's less than 0.05%. But the chemistry is the same. The difference is scale and time. Dr. Fred Taylor, one of the lead scientists of Venus Express, summarized it simply: Venus is what happens when a greenhouse effect runs away. It's not a metaphor. It's a mirror. That mirror reflects a terrifying possibility. If Earth's climate were to spiral beyond certain thresholds, if the oceans warmed enough to release vast stores of water vapor and methane, the feedbacks could cascade, locking in a hotter, denser, more humid atmosphere. The oceans might evaporate over millennia. Clouds of steam and carbon dioxide could form, thickening until the surface no longer cooled at night. At some point, the planet's infrared radiation could no longer escape to space. The balance would break. Earth would begin to resemble Venus, The threshold, no scientist believes such a transformation is imminent. But Venus Express forced the question, where is the tipping point? On Venus, that point came when the atmosphere reached just enough density to trap outgoing heat faster than it could radiate away. The energy imbalance grew, and the planet's temperature shot upward. On Earth, rising greenhouse gases are already shifting that balance, albeit on a smaller scale. Every ton of CO2 emitted slows the planet's cooling just a little. Every degree of warming adds a fraction more water vapor to the air. Venus tells us that feedback loops are not theoretical, they are real, and once they pass a threshold, they are unstoppable. The difference between Earth and Venus, said Dr. Colin Wilson, is not composition, it's luck and timing. Lessons written in fire. The irony of Venus's fate is that its catastrophe began quietly. There was no single explosion, no comet impact, no sudden warping of physics. It was simply too much sunlight and too much carbon dioxide, working together over millions of years. Venus teaches that small imbalances can destroy worlds. Its transformation shows that climate is not a gentle system. It is a knife-edge equilibrium. It can hold steady for eons, and then, once disturbed, it can flip into a new state faster than life can adapt. The planet's present atmosphere, dense, hot, and acidic, is not an anomaly. It is the end state of unchecked warming. Venus has already lived through the future we fear. The data's echo when Venus Express measured the isotopes of hydrogen in the atmosphere. It found a ratio that shocked researchers. The planet's deuterium to hydrogen ratio was over 150 times higher than Earth's. That means Venus once had oceans as deep as ours, but lost them all. Over time, sunlight split the water molecules apart, and the hydrogen escaped to space while the heavier deuterium remained. The ocean didn't vanish in a storm or a flood. It simply drifted away, molecule by molecule, until nothing was left. That discovery, more than any other, crystallized the meaning of the mission. It wasn't just about geology or chemistry, it was about impermanence. Even a planet's oceans can die. A planet that warns Venus's story is not only about loss, it is also about endurance. Despite its ruin, the planet remains stable. Its atmosphere, though toxic, circulates with mesmerizing precision. Its clouds shimmer with light. Its winds still race, and its chemistry still evolves. Venus persists, indifferent to tragedy. And perhaps that's the most sobering message of all. Because if Earth follows that path, life may vanish, but the planet will go on. It is not the world that dies. It is the living things that fail to adapt. Venus shows that the planet itself will always survive. But what lives on it may not. The mirror in the sky every evening. Venus appears in Earth's twilight. A brilliant, unwavering light just above the horizon. Ancient cultures called it the morning star, the evening star, the herald of dawn. To early astronomers, it symbolized beauty and constancy. To poets, love. Now, we know that its light is a lie, a reflection from the most hostile surface in the solar system. Yet it remains beautiful, because beauty and danger often share the same face. From Earth, we see Venus as a bright point in the sky. From Venus, if one could look back, Earth would shine the same way. Blue, delicate, luminous. Two mirrors, facing each other across space. One alive, one burned. The human reflection when the Venus Express mission ended. Its team gathered to discuss what it all meant. They agreed that Venus was not a lost cause but a lesson. A natural laboratory for understanding what happens when climate, chemistry, and time collide. Today, that lesson shapes more than planetary science. Climate models used to predict global warming on Earth borrow directly from Venus Express data. The study of carbon feedbacks, radiative transfer, and atmospheric circulation all trace their modern understanding back to the mission's discoveries. Venus, in death, has become the teacher of life. Tells us that habitability is fragile, that stability is temporary, that beauty can hide catastrophe, and perhaps most poignantly, it reminds us that the line between paradise and apocalypse is thinner than we ever imagined. The final reflection in a quiet control room in Darmstadt. After the last transmission faded, someone wrote on the whiteboard, "Venus is not a warning from the gods. It's a warning from physics. It stayed there for months. Venus does not threaten us. It merely shows us ourselves, sped up, amplified, stripped of mercy. Its history is not prophecy, but precedent. And in its molten surface and acid clouds, we glimpse both our origin and our potential end, the two extremes of what a living world can become. If we listen, if we learn, maybe we can keep the mirror from closing." In the next and final part, we return to the stars, to the broader story of the solar system and humanity's search for meaning beyond survival. Because Venus Express did more than reveal a planet's past. It redefined what it means to explore, to persist, and to see ourselves reflected in the cosmos. Part 14. The light beyond the clouds. There are moments in exploration when discovery becomes something deeper than science. When a mission, a spacecraft, or even a single image changes how humanity sees itself. For the team behind Venus Express, that moment came not in triumph, but in silence. When the final signal faded into static, there was no applause, only the quiet hum of computers, the soft buzz of fluorescent light, and a long, shared stillness. They had touched another world, one that would never touch them back. Yet in that distance, something transcendent had occurred. Through the glare of acid clouds and the roar of solar wind, through the furnace of a world that should have been impossible, humanity had reached out and seen itself reflected in fire. The light that was never meant to be seen. Venus was once imagined as paradise. Then it was revealed as hell. But perhaps it is neither. The data from Venus Express and all the missions before it paint a more complex picture, not of punishment but of process. Venus is not a fallen world. It is a completed one. The story is not tragedy but transformation. Every molecule in its sky, every crater and storm, every flicker of nightglow is part of a long, continuous evolution that began the same way ours did. The difference is only in direction. If Earth is the symphony of balance, then Venus is the echo of imbalance, a song played too loudly, too long. And in that echo lies the wisdom of survival. The light beyond the clouds is not sunlight. It is understanding. The legacy of Venus Express. When Venus Express began in 2005, it was seen as a small, low-budget mission, an experiment built mostly from leftover components of ESA's Mars Express. Few imagined it would become one of the most influential planetary missions in modern history. But what it achieved redefined how scientists think about worlds, climates, and even possibility itself. Its instruments taught us that Venus still breathes. Its winds, clouds, and chemistry are in constant motion. The planet's heat and pressure evolve dynamically, not statically. Volcanoes may still erupt, feeding sulfur into the atmosphere even today. Atmospheric loss continues, showing that the planet's evolution is still ongoing. And perhaps most surprisingly, Venus Express revealed that the planet, despite its extremity, remains a system in balance, a self-regulating machine stable in its own way. That realization changed the way we study exoplanets, too. Thousands of worlds orbit other stars, many close to their suns, many wrapped in thick atmospheres. Without Venus Express, we might never have understood them. Venus became the template for the unlivable, a benchmark for the limits of habitability. The eyes that follow every mission leaves a legacy that others inherit. Today, the story of Venus Express continues through its successors. NASA's Veritas will map the planet in 3D, seeking signs of tectonic motion and active lava flows. Da Vinci Plus will plunge directly through the atmosphere, analyzing gases as it falls, a modern echo of the 1980s Venera landers, but with technology that can survive longer and see deeper. And ESA's Envision, the European follow-up to Venus Express, will orbit in the 2030s with radar and spectrometers capable of revealing the planet's crust, its minerals, and even possible traces of past oceans buried beneath the rock. Together, these missions form a new era of exploration, one built on the foundation laid by that small, aging spacecraft that once danced along the edge of the inferno. When those new probes arrive, they will still find Venus Express there, not as a machine but as an idea orbiting invisibly in their data and designs. The human story, no mission to another world, is only about the planet itself. It's also about the humans who dared to reach it. For 8 years, a small team on Earth lived on Venusian time, tracking the spacecraft's orbit, predicting storms, analyzing radiation spikes, and adjusting trajectories. Their lives synchronized with a world 40 million kilometers away. They learned to read the planet's moods through numbers and graphs, the fluctuations in density, the signatures of wind, the spectral fingerprints of acid and light. And slowly, Venus stopped being a distant object. It became familiar, not warm, but intimate. Dr. Daniela Titov once said, "We began the mission studying a planet. We ended it feeling like we'd known a person." That's what space exploration does. It humanizes the cosmos. It turns the abstract into the emotional, the unreachable into the real. What Venus teaches humility. It shows that not every world is kind to life, that conditions we call normal are rare, fragile, and fleeting. It teaches perspective. That our atmosphere, our oceans, our delicate balance of temperature and chemistry exist only within narrow margins that physics enforces without mercy. Teaches continuity. That the processes shaping Earth today, volcanism, wind, carbon cycles, are not unique but universal. The same laws that sculpt Venus sculpt us. The difference is only degree. And, above all, Venus teaches responsibility. Because when we look at that bright point in the evening sky, we see not a distant planet, but a future we could create if we forget what balance means. A flame that endures. It is easy to think of Venus Express as lost. Its metal burned, its circuits gone. But in truth, the spacecraft endures in every piece of knowledge it left behind, every student inspired by its data, every new mission it made possible. It's there in the way scientists talk about planetary atmospheres now, with awe and caution, not certainty. It's there in the growing understanding that exploration is not conquest. It's listening. And it's there in the sky itself, whenever Venus rises before dawn or glows after sunset. A silent reminder that even in failure, we find illumination. The planet that burned away its oceans has become the light that guides us home. The final thought in the end, Venus Express's legacy is not a story of technology, or science, or even discovery. It is a story of relationship between worlds, between eras, between what we know and what we still dare to ask. Venus stands now as both warning and wonder, a world of ruin that still shines with impossible beauty. And as long as we keep looking through telescopes, through data, through imagination, we remain what we have always been. Creatures reaching toward the unknown, seeking meaning in light and shadow. Perhaps that is what exploration truly means. Not escaping Earth, but understanding it through its mirrors. Because beyond every cloud, beyond every loss, beyond every silence, there is always one more glimmer waiting to be seen. The light beyond the clouds. Epilogue. In the archives of the European Space Agency, there is a single audio file, just a faint, crackling signal recorded from Venus Express on its final day. Engineers sometimes play it for new recruits. It's not dramatic. There's no voice, no music, no transmission of words. Only static. But listen long enough, and you can almost imagine something within it. A rhythm, a pulse, a whisper carried from another world. And if you close your eyes, it sounds almost like breathing.